here we have the laws of electronic configuration. The laws of electronic configuration. How can we write configuration of element? If we don't understand these laws, it will be difficult for us to write the configurations of elements. Are we together now? So we're taking the laws one by one and how they are being applied. You understand? Good. So the first one is Albert's principle. So Albert's principle states that electrons will first occupy the lowest energy level before entering into the higher ones. Electrons will first occupy the lowest energy level before entering the higher ones. Are we together now? Now, in this case now, if I have this atomic structure, right? If I have something like this, good. If I have something like this, I'm using this as an example. Now, this is the lowest energy level. This particular one must click the bottom of 2 electrons, right? This one is 8, while this one is 8. I cannot write 1 and jump to here. This one will be filled completely before I will enter here. This one will take 8, right? I can't write 2, 1, 2, 3, 4, then jump to number 3. I must make sure that this second one is completely filled, which is 8 electrons before the higher one. This is the 1, 2, 3. This is the lowest, followed by this and by this. So this one will be filled out. The law is saying this one will be filled first before entering this one, and this one will be filled first before entering this one. So we cannot jump. We must count 1 before we count 2. That is what Albert's principle is saying. Are we together now? Good. The second one is Pauli's exclusive principle. Pauli's exclusive principle. This one states that electrons. This one says that any orbital with more than one atomic orbital, any orbital that has, let me use any orbital that has more than one atomic orbital. Example, PDF. PDF, they have more than one atomic orbital. P has how many atomic orbital? 3. D has atomic orbital 5, and F have how many? 7. So any orbital that has more than one atomic orbitals, example PDF. He said electrons will enter into the orbital single before pairing. Electrons will enter into the orbitals single before pairing. They must enter single before pairing. They cannot just pair, but they must enter single before pairing. For instance, look at what I'm saying. If I have like, I want to configure oxygen. Oxygen is here is 2 is 8. That is 6 will be outside. Like this. Now, this first energy level, number 1, I'll write 1 because I'm talking about number 1. First orbital is S. How many electrons are here? 2. You can take my sum of 2, right? I'm done with first. Second one, I've entered the second energy level, I'll write 2. That is second now. So the first orbital that starts every energy level is what? S. It will take how many electrons? Maximum of what? 2. Now, if I remove 2 here, how many are remaining here? 4, right? This 4 at which energy level? 2. Which orbital comes after SP? How many electrons are remaining here? 4. We write 4. Are we there now? Good. But now this one is linear configuration. Now, block configuration here. See where this law is applicable now. This block configuration. I'll have this. Electrons will be arranged in opposite spine. This is 2 electrons. I'll write 1s, right? I'll write this one again. This one. Like this. This is what? 2s. Now, this one contains only one atomic orbital. That is why you see 2 electrons only. S contains 1 atomic orbital. But P contains 3 atomic orbitals. So we will now have something like this. Because it has 3 atomic orbitals. Are we there? 1 atomic orbital. How many? 1, 2, 3 now. And each of these atomic orbitals will contain how many electrons? 2. I say P contains 3 atomic orbitals, each containing 2 electrons. If you say 2 plus 2, 4 plus 2, 6. That is why the maximum number of electrons P will take is how many? 6. Because each of the atomic orbitals will contain the maximum of 2 electrons. If you multiply through, you will get what? 6. This now, watch now. This is for S, 2 electrons complete. 2 electrons complete. This one is P. Is having 4 electrons here, right? This law says that if you have something like this, they must enter single first. Single. Now is 4, right? Is 4 electrons. I've entered single. That is 3. Remaining how many? 1. I will now start pairing. So this is not the configuration, right? This is the linear configuration of oxygen. This is the block configuration of oxygen. So this is what the Pauli's exclusive principle is saying, that in any orbital that contains more than one atomic orbital. Are you there? The electrons will enter into the orbital single before pairing. So they have entered single first. If electron is remaining, they will now start pairing. That is what it is saying. Are we together now? Good. So this one is Hong's rule. Hong's rule states that the maximum electron an atomic orbital will contain is 2, which must be arranged in opposite spine. Opposite spine. The maximum electrons an atomic orbital will contain is 2, which must be arranged in opposite spine. Watch. This is what it's saying. This is atomic orbital, atomic orbital, atomic orbital, atomic orbital, atomic orbital, right? This one cannot take more than 2 electrons. That's what it's saying. The maximum it can take is 2. That's why I have only 2 here. The maximum this can take is what? 2. Maximum this can take is 2. Maximum this can take is 2. Maximum this can take is 2. So the maximum number of electrons an atomic orbital will contain is 2. And these 2 electrons must be arranged in opposite spine. This is opposite spine. One is facing up and one is facing down. You know, electrons are negatively charged. So in other words, if you put them together like this, they will repel. There will be force of repulsion. They will push each other out. But as it is now, they are like this. That means there will be force of attraction. If they arrange the opposite spine, they can stay in this block. But if they arrange straight like this, head to head or tail to tail, they can easily repel each other because both of them are negatively charged. So that is what this law is saying, this one and this one. So now we have established the 3 laws which will guide us in the configuration of element. Is it clear? Good.